Okay, so throughout this entire 4 series bootcamp, we're going to be coming to this repo a lot. So it's github.com/algorand-devrel/bootcamp. And this repo is going to contain first all of the code along with all of our presentations that we're going to be doing throughout this bootcamp. Then if you go down here in the README at the bottom here, we've stubbed out links that will be added with the video recordings. So for today, what we're going to be doing is using this session1 directory. And in this directory, intro to Algorand is the directory we're going to be doing first. So this is going to be a node project using TypeScript. So to actually run this, if you have node installed locally on your local machine already, you can just go ahead and clone this repo and then follow along. But if you don't have Node ready or you're not sure if you have Node already installed, you can use this tool called the Gitpod. And Gitpod basically provides a developer environment in the cloud that is already set up for you to start developing on. So in order to use our Gitpod, you just have to come to our README and then click on this link. And what that will do is it'll take you to Gitpod. It'll ask you to sign in, and you can sign in with GitHub. Now I've already made an account, so I just click sign in and it automatically signed me in. If it's your first time, you might have to give it permission and allow Gitpod to log in with your GitHub. But once you do that, you will see this screen where it's basically VS Code in your browser. And if it's your first time going to this Gitpod link, like it is mine here, what it's going to do is install AlgoKit. So right now, I'm not going to be going over AlgoKit. So we're just going to create a new terminal. Ryan's going to be going over AlgoKit a bit in depth later. So what we're going to do here is now we're in our Gitpod environment ready for development. Again, in our session1 intro to Algorand directory, that's where we want to be. So we want to go to cd session1 intro to Algorand. And in here, we take a look at the files in here. This is a node project and it's using yarn. So in order to install our dependencies, we simply run yarn. While that's installing the dependencies, I'm going to go ahead and open up this index.ts file. And this is the file that I'm going to be using today to go over Algorand concepts. Now, I should mention that you don't need to follow along at this part. This is mostly served as a way to tell you information about Algorand while also showing you what it looks like in the code. But here we're not actually making a functional app or anything. What we're going to be doing is transferring an asset on testnet. So first, in this index.ts file, the most important thing here is our import algo SDK from algo SDK. Our SDK provides various methods and wrappers for our APIs for connecting to the network. Here we're using JavaScript, and it's just called algo SDK. We also have an SDK for Python, an SDK for Go, and an SDK for Java. And those are our 4 official SDKs. And then we have a bunch of other SDKs that are community driven, that aren't official, but are still great ways to develop on Algorand. For example, we have a C# .NET SDK, we have a Unity SDK. There's a lot of ways to build on Algorand, and they all work, whether it's official or not, relatively the same. Now, these next couple of imports are just things that I import to help with the demo purposes. These aren't necessary for Algorand development. And then this final import here, we're importing information about a smart contract. I'll get in depth into that when we reach it later down in the demo. And now these couple of lines of code are just, again, for the demo purposes, not essential to Algorand development. So I'm just going to go ahead and go down into our main function. And this is where we actually get started interacting with Algorand and creating our first account. So taking a look at this code, the first thing we do when we want to interact with the blockchain is make sure we have an account. Now, there are a couple ways to get accounts. You can use a wallet like Para, or you can use a local key management daemon or KMD, which is basically like a local wallet for getting all your local accounts, or you can simply create an account with the SDK. And so that's what I did here. I created an account using algo SDK.generate account, and then that generates an account object with an address and a secret key. And so if I go ahead and run this code now, npx dsx, because it's a TypeScript file, index.ts, I can see here I now have a mnemonic and an address. And this is the address that I'm going to use to fund the account and the address that I'm going to use to send transactions to the network. So before I can send transactions to the network, I need to first fund the account. And in order to fund the account, I want to be able to check the balance. So in order to check the balance of the account, I need to connect to the network. And I can do so through what we call an AlgoD client. So an AlgoD client is basically a connection to the node HTTP endpoints. And this is how we interact with the blockchain. So what we're doing is we're creating an AlgoD token. In this case, we're connecting to a public API, so there's no secret token, so it's just an empty string. Then our AlgoD server is going to be testnet.api.algonode.cloud. Algonode is a public API provider. Here we're connecting to testnet. You can also use Algonode to connect to mainnet if you want. And then port, we're just leaving it undefined because we're connecting through HTTPS. And then we pass in all those things to our AlgoD v2 constructor, and that will now give us an AlgoD client that we can use to interact with the blockchain. So now what we want to do is we want to get information about our account. So we've created this account here, this DX2 address, and we want to see information about that account from the network. So what we're going to do is we are going to get information from our AlgoD client by calling AlgoD client.account information and passing in the account address. Now, this piece of code right here, all it's doing is preparing the request to the node. So it's preparing what information we want to get from the node, and then this .do is what's actually sending it to the node. So this is an asynchronous call, which is an HTTP request. So we're going to do a wait on it, and this will allow us to wait for us to get the information back from our AlgoD client, and then we're going to log this information. Let's go ahead and take a look at what that looks like. So we can see here, our Algorand node has a bunch of information about this account. And right now the amount is 0, and it doesn't have any local states, doesn't have any apps or assets, and its minimum balance is 100,000. We'll be getting to this a little bit later. And then we also have all these other information about apps and assets and various things about the account as well. We're not going to be going too in depth into this. The important thing here is that we've asked the network, tell us all the information about this account, and this is what it gave us. So now what we want to do is we want to actually dispense algo to this account, but we want to have our script wait until the algo is dispensed before we can continue. So what we have is a wait for balance function, and we're going to do a wait AlgoD client account information, just like we did before. And this time we're simply going to get the dot amount. So that's how much algo is in this account. And we're going to simply keep calling this function until the balance is not 0. So if I go ahead, it's telling us we need to dispense algo. And I'm going to go ahead, go up, copy the address, go to my dispenser here, paste in the address. I'm not a robot, and dispense. This should just take a couple of seconds. And we've now seen that the algo has been dispensed. We can now see, if we take a look actually at this transaction on our Explorer, we can see the dispenser has sent 10 algo to this DX2 account, which is indeed our account. Okay, so now at this point, we have some algo in our account, and we've waited for the balance. So we know we now have a balance on the account, and the account's been funded. So now let's get ready to send our first transaction. And I said we're going to be sending an asset, but before we do that, we're just going to be sending a simple payment transaction, because that's the easiest kind of transaction on Algorand. And we just want to show you what sending a transaction looks like before we get into more complex stuff. First thing we're going to do before we send any transaction to the network is get the basic information that our node needs for that transaction. And we commonly call this the suggested parameters or suggested params. And in our JavaScript SDK, in order to get that, we ask our AlgoD client to get the suggested params, and then call .do to send that request. And what this will do is return all of the information we need to add to all the transactions that we want to send to the network. So if we go ahead and run that, we can see our suggested params object contains some information about the fee, information about the round, and information about the network we're connecting to. Now, again, we're not going to go too in depth into what each of these means. We'll be going over fees a little bit later. But the important thing to note is that suggested params contains all the information that we're going to include in all of our transactions that we're sending. This is basically asking the node, hey, I want to send a transaction. What information should I include in that transaction? So what we've done is we formed the transaction. We've set all the information about the transaction that we want to send. But before we can send any transaction to the network, we need to sign it. So we're going to do a variable sign payment transaction. And we're simply going to call payment transaction dot sign transaction. And the argument here is the secret key of the account, or the private key of the account that'll be used to sign it. So now in this variable, we can see here it returns a uint8 array. So this basically means signed payment transaction is binary data of the signed transaction that we eventually want to send to the network. In order to send it to the network, I'm going to call algoclient.send raw transaction. And this send raw basically means we're sending binary data, which is what this transaction variable is. And then again, we're calling .do to actually send it to the network. And then we're going to log the transaction ID, and then we're going to wait for the transaction to get confirmed. So this send raw transaction, all it does is send it to the network, but in our front ends, when we're later developing, we want to make sure that the transaction actually goes through and is confirmed by the network. So what we do here is we call algo SDK.wait for confirmation. And what this does is it takes in our algod client. So this is our connection to the network, the transaction ID that we want to wait for, and how many rounds we want to wait. In general, we recommend waiting at least 3 rounds. In production, you probably want to wait a lot more just to make sure you handle cases where the network is a little bit congested. On Algorand, every transaction is 3.5 seconds. And so 3 rounds means roughly wait 12 seconds. And if it isn't confirmed in that 12 seconds, then this method will throw an error. So what we're basically going to do is send our transaction as binary data to the network here, then wait for that transaction to get confirmed, and then we're going to log the confirmation. Just going to go hit enter to do all that. So we're sending it to the node. This is our transaction ID. Now we're waiting roughly 3.5 seconds for it to get confirmed. And we can now see that the transaction has been confirmed. And that's how quick it is to send transactions on Algorand. We can go ahead and open this transaction. We can see indeed we sent 0.5 algo. Then we can see that it's sending from our DX2 account back to the dispenser. So what we've done here, form our transaction, sign it, send it, wait for it. And that's the general paradigm of what Algorand SDKs look like. You first form your transactions, then you sign your transactions, you send them to the network, and then you wait for confirmation. Now, later on, we're going to be using AlgoKit, which does a lot of this for us, but that's the common pattern of what you do when you're manually working with our SDKs.